We're going to solve equations, but now instead of having one step, we have more steps. We have maybe 2 steps, maybe 3 steps. And as we keep going, there's going to be more and more steps along the way. So let's see a problem that they already did. So these problems are already done for you, and let's kind of look at them and look through the process of how they did it. If I look at this first one right here, there's a lot going on in this problem. Do you see how they moved the 2x and the 3x next to each other so that they were right there? We've talked about like terms before. So they move the like terms next to each other. So if we think through that, if somebody had 2 x's and then they gave us 3 more x's, total we should have 5 x's. So they took this and added it together, and that's how we got here. And there's my minus 7, there's my equals 13. And then they did opposite operations. Just like in the remember the problem where we added 6 to both sides? Well, it's already being subtracted, so the opposite would be to add it to both sides. And then we get here and we realize, well, x still isn't alone yet. And so then we divide by 5 to get our final answer. And we also talked about the fact that we could plug it back in to check our work. All right, are you ready to try some?
Yes.
Okay, so let's put some friendly reminders off to the side. First friendly reminder is to do opposite operations. Opposite. Meaning, if you have something that is being added, the opposite would be to subtract it. If you have something that's being multiplied, the opposite would be to divide it. So if we have something added, the opposite is subtract. If I have something subtracted, what's the opposite? Add. If I have something multiplied, divide. And if I have something divided, multiply. So remember what your opposite operations are and what those look like. Another friendly reminder is anything you do, you have to do it to both sides. So you have to do everything to both sides. Meaning if you add 7 to one side, that's fine, as long as you also add 7 to the other. And then the reminder I gave you a minute ago is you can check your work. How do you check your work? You can plug in your answer and make sure that it truly does give you the right answer. All right, are you ready? Woo-hoo. Okay, here we go. Whenever we are solving, we want to get the variable alone. Do you see how this is my variable right here? It's an x. Okay, so we want to get it all by itself. So right now, it's got 2 things going on. It's got 8 being subtracted from it. It's got 3 being multiplied to it. We always deal with this addition or subtraction piece first. If I want to get rid of a minus 8, what is the opposite of subtracting 8? Adding 8. So we're going to add 8, but remember, to keep it balanced, we have to do it to both sides. So this is going to cancel. Boom, gone. So I have 3x equals, what is 4 plus 8? 12. And I hope more than Hayden is out there thinking through this and like, yeah, that's how we do this. Okay? Now, does this look like a problem we did last week? Yeah, this looks like the stuff we were doing last week. If we have two things that are right next to each other, what is really happening there? Multiplying. So we want to do the opposite, and the opposite of multiplying is dividing. So I'm going to divide away the 3. So the 3 goes away. X equals 4, because 12 divided by 3 is 4. Okay, so again, these are two-step problems because, well, 1, 2. So we're going to have a lot of problems where we're doing two different things. Some might have another step on top of that, but we'll get there. All right, take a look at number 2. Do you see my variables up here? We're trying to find B. Okay, let's always deal with what's being added or subtracted first. If I have a minus 4, how can I get rid of a minus 4? Hayden can answer. Add 4 to both sides. So B, and then we have that symbol, and then we have a 2. This is gone. I like to cross stuff out in math. I feel like it's very satisfying to like, gone, it's not there anymore. All right, now, I didn't say what this symbol was for a reason. I called it that symbol. What is that symbol? What is this? Yes. So if it's divide, what do I need to do? Multiply. So I'm going to multiply each side by 2. So these will cancel. B equals 30 times 2? 60. Nice. Okay. So again, additional steps today. Still the same thing we were doing last week, but more steps. And so this is what you're going to be working on the ALEKS tomorrow, is you're either going to have one step like what we had last week, or you're going to have multiple steps like what we have today. Make sure you're adding these up. All right, let's look at the next one. Do you see how it gets trickier? Yeah. Okay, so kind of like the example above, do you see how we have two things that both have y's? Let's combine those before we do anything else. We had a unit on like terms. Oh, I want to like 7, but if I have 5 y's and somebody comes and takes 2 of them away, I have 3 y's left. So my first step is going to be to combine those like terms, because then the problem looks a little simpler, right? Subtract 4, I like it. We always deal with whatever's being added or subtracted. So let's subtract away the 4. So this is gone. Love crossing stuff off in math. Makes my day. 9 take away 4 is going to give me what?
3. Wait, no.
5. This one isn't going to come out nice, but that's okay. What should I do next? Divide. So these two things, remember, when they're right next to each other means they're being multiplied. So the opposite of multiplying is to divide it away. So boom, gone. Y equals. All right, so now let's see what 5 divided by 3 is. It's going to give me a decimal because I know that's not a nice number.
1.666.
Yeah, 1.6 repeating. And do we remember what symbol we put over the 6 if it continues? Yes. So if the 6 continues forever, or whatever number, doesn't have to be 6, could be something else. If that number continues forever, we put a line over it to show that, because that's kind of our shorthand notation. Because do you want to write 6 forever? Probably no, would be my guess. All right, how we doing? We okay? We're surviving on a Tuesday. Okay, look at number 4. Number 4 is a little bit trickier than the rest because do you see how I have parentheses?
Do we still add 5?
Well, before we even do that, we're going to distribute. Do you see how you have this 3 out front? Yeah, we are going to distribute that 3 in. What do we know 3 times x is?
3x.
3x. And I'm going to just rewrite my 14 and my equal sign. What do we know 3 times -2 is? -6. Okay, so my first step was to go ahead and distribute through. So 3 times x and then 3 times -2. You need help writing some of that stuff down with us? I hear ya. Still got to get some stuff done. All right, now, do you see how you have like terms right here?
Yeah.
Yeah, let's combine those first. Now, the good news is I'm not going to give you anything this tricky on the classwork. So you need to be able to do problems like 1, 2, and 3. This one's a little bit trickier, and it's almost an example of stuff that's going to come later. So it's headed our way, but it's not here yet. Okay, hold please. So Hayden's a step ahead, and he's already combining them. So if on your calculator you did -6 plus 5, do we agree with Hayden that's going to give us -1? Yes, no? -6 plus 5? Okay, now does it look like the problems we've been doing? 2 steps in. Does that look like the ones up here? Yeah. So we're going to deal with whatever's being added or subtracted first. How can I get rid of this -1? Add 1. So we're always doing the opposite. This is gone. 15 equals 3x. And then divide by 3. Nice. And x equals 5. Now, watch what happens if I plug this 5 back in. It should give me a true statement. So I'm going to check my work on this one. 5 minus 2 is 3. 3 times 3? 9. 9 plus 5, is that 14? Yeah, perfect.
I just did 3 times 5 minus
3 times
1. 5
Oh.
minus 1 equals 14.
3 times 5. Oh, I see. You came down here and did it at a lower level. Gotcha. At a level that was further in, basically. Yeah.
Mrs. Bessel, does it matter if I write 14 equals 3x and then write 5 equals x?
Yeah, if you had them flipped, if you had 5 equals x, that's fine too. Yeah, you could have it flip-flopped. You could also have, I'm not super picky right now. Remember, we did have a unit on fractions, and so in that unit, you had to have everything fractions. But in this unit, I'm fine with decimals or fractions. Okay? So either one would be good. Okay, flip to the back. Again, the problems are missing. So go ahead and add these to your paper real quick. So step 1, put the problems on there. Okay. Now these are a little bit different in how I'm going to attack them because of the fact, do you see how the stuff that's being added or subtracted is up top, like it's all together in the numerator? That's going to make a difference. Alright, so it's going to change what I do first. So here's my plus x, and that x, that positive x, I would like to please get alone. Now, before I can deal with adding or subtracting the 4, do you see how everything's being divided by 5? And that's a bigger problem, so we need to deal with that first. So when everything is in a fraction, being divided by 5, what's the opposite of dividing by 5?
Times.
Yeah, so the first thing I'm going to do with this one is different. I'm going to multiply each side by 5 first, so I can get rid of the fraction. Alright, so then these 5's will cancel. So I get 4 plus x equals negative 3 times a positive 5.
50.
Careful.
Oh.
Negative 15. Okay. Now, this should look like a problem we saw last week. X isn't quite alone yet. So again, remember what you're trying to get. You're trying to get this x all by itself. How can I get rid of that plus 4?
4 minus 5.
Yeah, we've got to subtract it away. Yep, opposite of adding is subtracting. So these will cancel.
19.
X equals, I almost love 19. What it should, yeah, it should be negative 19. Because if you have negative 15 and then you subtract 4 more on top of that, you should have negative 19. Alright, number 6, we kind of had one like this on the front. What should I do with that negative 10 before I do anything else?
Times it by y and negative.
Yeah, I need to distribute it. So remember our fancy word for sending this through the parenthesis is to distribute. We're multiplying it in. Negative 10 times y is going to give me negative 10y.
And then negative 30.
But is it?
Positive 30.
Positive 30, because a negative times a negative is a positive.
And we do 10. Wait, no, 30.
Yeah, so this one's more like the front. So do you see how it's not a fraction? This one's like the ones on the front where we're going to deal with the addition or subtraction first. How can I remove my friend 30?
You do 30 minus 7.
Yeah, we're going to have to subtract it away. It's positive, so we're going to subtract it. So negative 10y equals 7 minus 30. I'm going to get negative 23. Alright, Hayden can't answer again. Pressing the mute button on Hayden. What can I do next to get rid of the negative 10 with the y? So the negative 10 is being multiplied to y. The opposite would be? Yeah, divide it. And we're going to take the negative 2. So not just dividing by the 10, but also the negative. So everything disappears, right? All the things are gone. So y equals, on your calculator, you're going to go negative 23 divided by negative 10. Make sure you know how to type them in, because the calculators are nice, the technology is nice, but if you don't know how to use it, then it almost doesn't matter that we have it. Hit enter. Do you get 2.3? Okay. And again, we can double check our work if we want to by plugging stuff back in. Alright, last one for the notes section, then we're going to do a little bit of classwork. What should I do first? No. I still have my remote.
I know. That's why I said I can't.
Yeah, no you can't. So what is happening to everything? It's being what by negative 14? What is the sign? Divide. So if I want to get rid of it, I'm going to multiply each side by negative 14. And when I do that, these cancel. I get negative y minus 2 equals negative 1 minus 14 more. What's that going to give me? You can do it on your calculator if you need to. negative 1, or sorry, not minus 14 more, times. Negative 1 times negative 14. So a negative times a negative is a positive. And then 1 times 14 is 14. Okay. All right. Now, how can I get rid of that negative 2? If it's being subtracted, I should add it. So this cancels. Negative y equals 14 plus 2 is 16. All right. So if negative y equals 16, what should positive y equal?
14.
Careful. We're not going to change numbers. Yeah, negative 16. The signs are just going to flip-flop.
Divide by negative 1.
Or divide by negative 1 or multiply by negative 1. Any of those are ways to think about
I thought
it.
you said 2 minus 16, because that's 14.
Oh, I see. Gotcha. All right, we don't have a ton of time, so I'm not going to give you as many of these as I originally was, because I don't think we're going to quite make it through. So what I would like to do is just 1 through 5 on here. So I'm going to hand this out, and so we can cross out all the rest. And we're going to go 1 to 5 only, because I think by the time we get through them, ask questions, and you check in with me, I think that's about all the time we're going to have to make sure we've got this.